Good evening, everybody. Welcome to Chem 1105 with your host, me, Dr. White. By the way, Jim, you're welcome. Good evening again. All right, tonight I will be doing a short review of things you should know for the final exam. I'll also show you where you can get more practice and reviews for the final exam. All right, let's first go to Blackboard. And this coming Monday, the 13th, I will be giving the final exam online. And just like the other tests or our 4 tests, by 8 a.m. or earlier, probably earlier, I will send out a password in an email that allow you to open up the password protected final exam PDF file, which will be in the assignment area Blackboard. You'll have until Tuesday, 8 p.m. to finish the final exam and upload your answers, final exam answers, a single PDF file to the assignment area Blackboard. When I've done this face-to-face, and yes, I've taught 1105 many times face-to-face, usually most students are done within 70 minutes. But I'm be nice, take up to 3 hours if you need it. You shouldn't, but you will. Now, the final exam will cover all the material this semester in 1105. Now, the final exam has 27 problems, 8 pages. Some of the problems are multiple part. There are 5 multiple choice questions. Now, to help you along, notice I have points based on material from each test. Test 1, 16, 2, 44, that's a lot of mole stuff, and 3, 29 points, and 4, 21. And it adds up to 110 because there's 10, 5 and 5, 10 bonus points. Am I nice or what? Don't answer that. All right. And I have reserved the right to subtract up to 50 points if anybody doesn't follow instructions or upload your answers on time. And by Sunday, 5 p.m., the following Sunday, or a lot earlier, hopefully a lot earlier, I'll send out an email that your scores and also your final exam score and your final grade will be in Blackboard. The school system that you get your grades from, usually you have to wait 24 hours after I put them in the system to see them. All right. Now, this is important. Now, I have here 511. I've decided, something, I'll be nice again. Shh, don't tell anybody I'm being nice. And I've extended the amnesty program for labs 7 through 13. You have until this Saturday morning, like 4 a.m., I think I said it, to hand in the labs, one of the labs that you didn't do or haven't done. Any late labs like 7, 8, or 9, I'll take off 1 point because you should have gotten on time, but you can still get a lot of points, which will help your grade. Now, if you do hand in a late lab, please send me an email for the names of these. Also, please, by, say, Sunday morning, check Blackboard and make sure for every lab you handed in, you have points. And if you don't, send me an email so I can look into it to make sure you get points. I had something pop up on my screen from one of my software, CCleaner. But anyways, so make sure you hand in your labs 7 through 13. If you haven't, they're easy points. Don't tell anybody I said that, but they aren't that hard. And they help your grade. If you don't, that hurts your grade. And I don't want to see that. And when you do hand in a late lab, make sure you send me an email so I know to grade it. But check Sunday morning to make sure I've graded all your labs. All right, let's go to the syllabus. If you go to page 15 of the syllabus, you'll see week 16, and you'll see all these different videos. And these videos, I do a full-blown couple-hour review of all the material. Let's take a look at one. And this is the one. Who's that handsome guy? Wow, I really like the way that top he has on. I think I should buy it. Oh, it's me. Uh-oh, it's bad humor night. But anyways, if we look at the description, it says final exam review. And the next one too. And you got a couple hours watching me do important problems like here. Use proper significant measuring pressure. One is millimeters of mercury. Here's grams of CO2. You want to go to mole. And the one before this and the one after, there are a total of 4 of them in that list right here of week 16 that you should watch for review. It will help you. The other way you can also review for final exam is you all have your final exams. You also were sent emails with links to the video with the answers, and use your hourly exams as practice problems for the final exam. Will I put the same problem on? No. But will I put similar ones on some of the more important ones? Of course. Now, a couple other things I want you to be aware of. If you go to the lecture section of Blackboard, you'll find a file called Important Information, Final Exam. And the last 2 or 3 pages, I forgot how many pages, 3 pages, will have all this information you see right now that you don't have to memorize. Years ago, I used to have students of mine in 1105 would have to memorize this. And I realized by testing your chemical knowledge or your chemical knowledge and your memory. And I decided I should just test your chemical knowledge, not how good your memory is. And therefore, you should be familiar with stuff like this. You're right. I am a sharp dresser. I like my top tonight. It's like winter out again. All right. Now, there's another thing let's look at. You've seen this periodic table. Let's go through the review of the periodic table. You should know the atomic symbols and names for the 37 key elements that we've talked about all semester, like H is hydrogen, C is carbon, O is oxygen, Cl chlorine, Ar, one of my favorite, argon, because I used a lot of that when I was in grad school. Same thing with a lot of carbon, oxygen, and hydrogens. Now, if you look at the number in the upper right-hand corner, the atomic number, like for carbon 6, that number tells you how many electrons and how many protons are in that atom or element. Again, the atomic number tells you how many electrons, how many protons are in that element. Carbon 6, oxygen 8. Underneath the number is the atomic weight. And on the final exam, like tests 2, 3, and 4, it will say, please use all atomic weights, the 3 significant figures. And you've learned by now, I hope, how to round off. And 12.011 to 3 significant figures is 12.0. Oxygen, 15.999. The 3 significant figures is 16.0. That you should know. Now, The numbers on top, which are in Roman numeral, and a couple years ago I found out they don't teach Roman numerals in grade school like when I was in grade school. By third grade, I think we had learned those. But anyways, I have numeric one in red, 1, 2, 3 over here, 4. And those are the valence electrons. And remember, the valence electrons are the outermost electrons of an element. And if we look at carbon and except all the elements in a column have the same number of valence electrons as the number on top. Hydrogen 1, lithium, sodium, potassium 1, carbon 4, nitrogen 5, oxygen, sulfur 6, fluorine, chlorine, bromine, iodine 7, and the noble gases, helium, neon, argon, krypton, and xenon all have 8. And that you should be familiar with. Now, in the practice problems, we have both practice problem and practice problem answers for the final exam. And hint, you should know how to do these problems. Big hint, you should know how to do these problems. Did you get the message? You should know how to do these problems. Really? Let's go through some of them. No, that's not what I want to do. All right. Now, how many electrons and protons? Well, you find the atomic number, and that gives you the answer. And remember, we just said carbon has atomic number of 6, so it has 6 protons and 6 electrons. Now, how many valence electrons are in an element? And that's the number on top. As you see here for oxygen, it's 6. So that tells you oxygen has 6 valence electrons. Now, you should know how to draw the Lewis structure of an element. How do you do that? You have one dot on each side for each valence electron, and you do not double up. Put 2 dots on each side until each side has 1 dot. So carbon has 4 valence electrons. How do we know that? Carbon, red on top, valence electrons. And you'll be given this periodic table like you've done all semester in the download area of the final exam assignments in Blackboard. So carbon has 4 valence electrons. Here's the chemical symbol and a dot on each side. Now, we also learned how to do Lewis structures for molecules. And water, and by now I hope you've all learned, water has a chemical formula, H2O. I hope you all learned that or knew that. And you have 2 hydrogens. Each hydrogen has 1 valence, and oxygen 6. And when you share electrons, you form a chemical bond. Remember, there are 2 types of chemical bonds: ions, or ionic bonds, which is transfer of electrons from one atom or group of atoms to another atom or group of atoms, and a covalent bond, which is sharing. I don't know why I came up with always doing this. By the way, this is my imitation of the knuckle couplers between railroad cars and a freight train. Dr. White's a railroader, model railroader. But a covalent bond is sharing of pairs, that's 2 of electrons. And each element wants to get an octet, 8 valence electrons, except hydrogen's octet is 2. And in water, you have 6, and then 1 from the hydrogen, 1 from the oxygen appear there. Same thing here. Now, we talked about how to find what cations or anions are formed from the elements. And then when you form a molecule from ions, remember, all molecules have a net zero charge. And therefore, let's look at calcium chloride. I don't have it here, but I do have it here. What's the simplest formula for these two ions, calcium +2, chloride -1? All molecules have a net zero charge. If you find an example that breaks that rule, let me know and we'll be rich beyond my wildest dreams, which goes well beyond me having my own Ferrari, Lamborghinis, and fighter jet and island. A lot more. It doesn't happen. All right, what this really means is calcium is a +2 and chloride is a -1. And when you add this together, it has to equal 0. Well, it doesn't. You can't change the charge, but you can change how many. To get that to 0, I need 2 of those. So what does that mean? The simplest empirical formula for calcium chloride, 1 calcium and 2 chlorine. And those are the little white pellets you throw on your sidewalk and driveway when there's ice and snow there you want to melt and it's real cold. Now, next we talked about the mole. And the mole is an accounting unit of a chemist. And here are 4 important relationships with moles. 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And 1 mole of an element equals the atomic weight of that element in grams, and 1 mole of that compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights in that compound. So with that knowledge, let's look at number 5. How many molecules are in 8.574 moles of HCl, hydrochloric acid? We're trying to find molecules of HCl, and you've learned all semester, I use a question mark to say, what are we trying to find? And this is what we're given. If this is what we're given, and we have some sort of ratio that we can convert, what units do we want our answer to be? And well, we figure that out here. Molecules of HCl. And now it's time to use my good buddy, and hopefully by now your good buddy and friend, unit analysis. Whatever we're trying to get to goes on top of the ratio, the units. Whatever we're trying to get rid of goes underneath, and it really should have moles of HCl. Oops, don't look, I forgot to write that down. And where do we get this ratio? Remember, when you have A equals B, you can write 2 ratios, A over B, and these are not equal, they're separate ratios, B over A. And also let me remind you, anything divided by itself equals the number 1. It's gone. So with that in mind, If we look at important information, final exam, we're trying to find the relationship between moles of a compound and molecules of a compound. 1 mole of a compound equals Avogadro's number of molecules of that compound. Therefore, what do we put for molecules of HCl? 6.02 times 10 to the 23rd. What do we put for moles? 1. Now, when you do the math, remember, it will say on the final exam, just like tests 1, 2, 3, and 4, use proper significant figures for all calculated answers. And remember, for multiplication division, you get the same number of significant figures in your answer as the number with the fewest significant figures that you're multiplying and dividing by. Boy, this review work was thirsty stuff. And therefore, this is 4 significant figures, 3, and the 1 is an exact number which has no row. Therefore, your answer should have 3 significant figures, and it does. Now, the important thing you should know how to do is calculate the molecular weight of a compound. And once again, important information, the molecular weight of the compound is the sum of all atomic weights in that compound. So for this compound, C2H8O, that's ethanol, that's the molecule you find in beer, wine, and hard spirits that if you drink too much, which I'm not implying you should, you get inebriated, drunk. But anyways, you shouldn't. All right, so what's the molecular weight of ethanol? It has 2 carbons, 8 hydrogens, 1 oxygen. It's the sum of all atomic weights. Each carbon is 12.0, the 3 significant figures, hydrogen 1.01, oxygen 16.0. Do the math, add it up. Now, when you add numbers, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. Highlight my special effects. But anyways, this is 1, 2, 1. This has 2 to the right of the decimal. You can't see it right after the 8. But if you look hard enough and believe it's there, there's a dot there. And therefore, you round this off to 1 past the decimal, keep the 0, use the 8 to round off. That's 5 or higher. The 0 is increased by 1. That's the molecular weight. Now, let's go to number 8. How many grams of sodium hydroxide, NaOH, are in 34.5 moles of sodium hydroxide? And here, we're trying to find grams of NaOH or given moles of NaOH. Now, if you go to important information, final exam, which I already wrote on here, but let's look. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of the compound is the sum of all atomic weights. With that knowledge, again, the only number I have to start with is 34.5 moles of NaOH. What units do I want my answer to be in? Well, we figured that out. Grams of NaOH. And if we had a ratio, what goes on top and up below? Well, use your good buddy, your good friend, unit analysis. Grams of NaOH goes on top. Moles of NaOH goes underneath. Remember, 1 mole equals the molecular weight of the compound. So on the top here, we have to calculate, because Dr. White was mean and didn't give us the molecular weight of NaOH. And the molecular weight is the sum of all atomic weights, 1 sodium, 1 oxygen, 1 hydrogen. Here are the atomic weights, you add it up, round it off, and you get 40.0. 3 significant, 3, 1. Your answer should have 3 significant figures. Remember, 1 is the exact number. And number 9 is similar to that. All right, let's look at number 10. How many grams of hydrogen are needed to react with an excess of chlorine to make 125 grams of hydrochloric acid. And now I need to remind you something which you did have to learn on your own, and that is the coefficients of a balanced chemical equation. Let's put one up on the whiteboard. Here we have a balanced chemical equation, and the coefficient, the number in front, when there's no number, that's assumed that's the number one. And this gives you the molar relationships. What this really means is there's 2 moles of hydrogen reacting with 1 mole of oxygen to make 2 moles of water. So the coefficients give you molar relationships, which you will need to use for the following problem. So what are we trying to do? First of all, hint, we're given a balanced chemical equation. And that tells you you need 3 steps because we're trying to find grams of hydrogen. We're given grams of HCl and a balanced chemical equation. If you go to important information, mass calculation, mass meaning gram calculation for reactions, you need 3 steps. Whatever you're given in grams, you can convert to moles of that compound. Whatever you figured out moles in step 1, you convert to moles of what you're trying to find, the compound. And finally, the moles in step 3 of what you found in step 2, you convert to grams of that compound B. So first step, what are we given? Grams of HCl. We have to convert that to moles of HCl. Here's the grams. We want to get the moles of HCl. Time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Remember, 1 mole equals the molecular weight of a compound. So 1 mole, and here we need the molecular weight of a compound. And the molecular weight of a compound is the sum of all atomic weights. Hydrogen, 1.01. In case you forgot, the number underneath the chemical symbol is the atomic weight. You should round that off to 3 significant figures. For hydrogen, it's 1.01. For chlorine, 35.453 rounds off to 35.5. Oh, I got it right. Yay, Dr. White. And now we add them up, use proper significant figures, and the proper weight is 36.5. We put that in, get 3 significant figures. Now in step 2, moles of A to moles of B. A is what we were given, HCl. B is what we're trying to get to, hydrogen. So again, here's what I have to start with, 3.42 moles of HCl. I'm trying to get the moles of hydrogen. Once again, anybody been counting how many times I say it's time to use your good buddy, your good friend, unit analysis? Whatever we're trying to get to goes on top of the ratio, moles of H2. Whatever we're trying to get rid of goes underneath, moles of HCl. And where do we get these numbers? Well, we look up the balanced chemical equation. And the coefficients tell you the molar ratios. And when there's no number, it's the number 1. So for every 1 mole of hydrogen, we make 2 moles of HCl, hydrochloric acid. Whenever you see excess of something, that means ignore it, and I will. So for every 1 mole of hydrogen, I need 2 moles of hydrochloric acid. And this cancels out. I'm left with moles. 1 and 2 are exact numbers, 3 significant figures, 3 significant figures. Are we done? No, we're trying to get the grams of hydrogen. So now we need step 3. Remember, that's given to you right here. Moles of B, which we just calculated hydrogen, H2. We have to convert to mass or grams of hydrogen gas, H2. And hold on, I just did something I didn't want to do. Wait. All right. How did I get that? Never mind. So step 3, moles of H2 to grams of H2. Well, in step 2, we figured out we have 1.71 moles of hydrogen. I don't have here, shame on Dr. White, bad Dr. White. You should see after 3.45 grams H2. And whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And where do you get this relationship? 1 mole. 1 mole of a compound equals the molecular weight of that compound. And the molecular weight is the sum of all atomic weights. And therefore, I have moles of H2. I'm trying to get the grams of H2. I did it again, forgot. Bad Dr. White. And what I'm trying to get to goes on top of the ratio. What I'm trying to get rid of goes underneath. This is the molecular weight. The molecular weight of hydrogen, there are 2 hydrogens in hydrogen gas, H2. 2 times the atomic weight, 1.01, is 2.02. And here you have that. This cancels out, 3 exact number, and here's the number. Now notice I have 3.45 or 3.46. As I've mentioned all semester, when you have multiple step calculations like this, there's 2 philosophies. One is round off at each step, and the other is round off at the end. I'm a round off at each person's step. I've been doing that all my life. And I've done it where I had to do calculations that hundreds of thousands of dollars were on the line, and it works. But the other way I think works also. So I calculate both ways. A lot of times they're the same. In this case, they're slightly different. Either one is correct answer. Now, another important skill you should have is knowing how to balance chemical equations. That means you have the same number of atoms of each type of atom on each side of the arrow. Remember, in a balanced chemical equation or any chemical equation, these are the reactants. And at the head of the arrow, you have the products. If you go back and look at the videos, you'll see my advice to you is do the hydrogen oxygen last. So in A, 5 carbons, we put a 5 in there because the only way you can change the number of atoms is by changing the coefficient, not the chemical formula. You can't do that. It's wrong. And I'll mark it wrong. So now I have 5 carbons, then I'll do hydrogen, 10 here, 5 here. Now add up all the atoms. 5 times 2 is 10, plus 5 here. Did I make a mistake here? This should be 12, not 5, not 10. And that would give me 6. And that's should be wrong. I made a mistake here. But anyways, you get the feeling. All right, let's move on. Go back and look at the tapes and practice problems. All right, we talked about solutions molarity. Capital M is molarity. What does 4.56 capital M NABR mean? That's 4.56 moles of NABR per 1,000 milliliters. And that's molarity. And if we look at important information, let me clean up a little. Important information, final exam. Here I give you molarity, which is capital M, moles of solute per 1,000 milliliters. So the question is, how many moles of NaF, sodium fluoride, NaF, are in 512 milliliters of 1.45 capital M NaF solution? We're trying to find moles of sodium fluoride. We're given milliliters, and we're given this number, 1.45 capital M NaF. Capital M, molarity, which means 1.45 moles of sodium fluoride, NaF, per 1,000 milliliters. So I have 512 milliliters. I want to get the moles of sodium fluoride, NaF, whatever I'm trying to get to, the units go on top of the ratio. Whatever I'm trying to get rid of, the units go underneath. Where do I get these numbers? From this, which I figured out from this. 1.45, 3 significant figures. The 1,000 is an exact number. Do the math, that's why it's 3 significant figures. Now, number 14, how many grams of sodium chloride are needed to make 341 milliliters of a 9.77 molar, that's capital M, NaCl solution? So we're given grams of NaCl we're trying to find. That's why there's a question mark. We're given the milliliters, and we're given this molarity. And we know this means molarity, 9.77 moles of NaCl per 1,000 milliliters. There's no way I can go from milliliters of solution to grams of solution. Here I went from milliliters to moles. That you can do in one step, but milliliters to grams, you can't. And if you look at important information, final exam, here we have the 2 steps for a 2-step molarity problem. First step, milliliters to moles, then second step, moles to grams. So let's do that. First step, milliliters of NaCl to moles of NaCl. Here's the milliliters, here's the moles. Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. Where do we get these numbers? From the molarity. This is exact number 3. I'm in my rut, 3 significant figures. Are we done? No, we're trying to get the grams of NaCl. We have moles of NaCl. And step 2, we go from moles of NaCl to grams of NaCl. And here we have moles of NaCl. We want to get the grams of NaCl. This goes on top. Moles go underneath. Important information, final exam. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights. So the molecular weight of sodium chloride, 1 sodium, 23.0, 1 chloride, the three significant figures, 35.5, it adds up to 58.5, put that in there, 331, you get 195. Notice it says both ways. That means if you round off at each step or at the end, you get the same answer. Now, next I started talking about gases. And remember on test 3, 15 points. And a problem similar to this, what is the volume of a tire containing 24.0 grams of nitrogen N2 gas at 101 degrees C and 745 torque? Now notice we're talking about nitrogen gas N2, and we're not changing any of the variables. And that means, and you're given the weight, temperature, pressure. And that means it's time for the ideal gas law. And if you look at important information, final exam, you'll see the ideal gas law, PV equal nRT. P is pressure, and this is important, in atmospheres. V is volume in liters. N is the number of moles. And T is the temperature in Kelvin. Plus R is the universal gas law constant, which for my class is 0.0821 atmospheres, liters, mole K. That's three significant figures, which you need to know. Also, a couple other things you need to know, which I give you. Converting from degrees C to Kelvin, Kelvin equals degrees C plus 273. And if you have to convert from torr to atmosphere or millimeters of mercury to atmosphere, this is important right here. 760 torr equal 760 millimeters of mercury equal 1 atmosphere. So PV equal nRT, we want to find volume. We have to get rid of the pressure on this side. Anything divided by itself is number one. Whatever you do on one side, you do on the other. So volume equals nRT divided by P. Now, right here, N is the moles. So we have 24.0 grams of nitrogen gas. We want to get to moles of nitrogen gas. Use the ratio we're using in analysis, your good buddy, your good friend. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And remember, 1 mole equals the molecular weight of a compound. So the molecular weight of nitrogen, N2, 2 nitrogens, each nitrogen has an atomic weight of 14.0. That's 28.0. You put it in here, and this is the number you get. Now, R, you're given. Temperature has to be in Kelvin. And degrees C plus 273 equal Kelvin. And the degrees C of temperature of this problem is 101. And we get 374. Now, here's a common mistake students forget. I'll say that again in slow motion. Here is a common mistake students forget. Pressure has to be in atmospheres. And if you look here, it says it in important information. Pressure has to be in atmospheres. So we have to convert 745 torr to atmospheres and use this ratio. Whatever you're trying to get to, the units go on top of the ratio. What you're trying to get rid of, the units go underneath. And remember, I showed you important information. 760 torr equal 1 atmosphere. Now, for this, these are both an exact number. Therefore, 3 significant figures, 3 significant. We put N is the moles right here. R is the universal gas law constant, which I give you important information. Final exam. T is the temperature in Kelvin. and P is the pressure. And you get 26.9 or 26.8. I'm a round off at each step person, but if you round off at the end, you get a slightly different number. Either one is correct. Next, what is the pH of a solution with the hydronium ion concentration 1.0 times 10 to the minus 3? Important information. What's the pH of a solution? Well, let's go find out. pH of the solution is minus the log of the hydronium ion concentration. And my gift to you all semester, if the hydronium ion concentration is 1.0 times 10 to the minus x, then the pH is x. Now, I don't have here, so let's first finish this problem. Put in there. Therefore, x is 3, pH is 3. One thing, I'm not giving you important information, but you should know. See how subtle Dr. White is for pH. At 7, that's neutral pH solution. Above is basic. Below is acidic. If I have a water solution at 7 and I add an acid, the pH will go down. If I have a water solution at 7 and I add a base, pH will go up. All right, when we talked about organic chemistry, I asked you to learn 2 reactions. In A, whenever you have a saturated hydrocarbon, molecule only carbon hydrogen atoms and react with oxygen combustion, the product you get is CO2 and water. For B, when you have a double bond reacted with hydrogen nickel, you break one of the bonds, each carbon of the double bond gets a hydrogen, but do you break carbon-carbon single bonds? No. So I start with 4, I better end up with 4. Remember, there's 4 bonds to carbon, so I can calculate how many hydrogens I need to put on each carbon. And with that, I think I'm done, or just about. Couple of things. First of all, I'd like to thank all of you for being in my class. Hopefully you enjoyed the way I taught it with my videos and being able to be available in my office hours and other times too on Zoom. If you did like what I did this semester, please go to ratemyprofessor.com and let people know about me. Now, if you didn't like what I did, go to ratemyprofessor.com and warn people about me. I hope you don't have to do that, but all right, don't forget, hand in the labs before Saturday morning, 4 a.m. Labs 7 through 13, you should hand it in. Also, Sunday morning, check your grades in Blackboard. If you don't see a grade score for a lab you handed in, email me and I'll look for it. All those should always be uploaded to Blackboard. Don't send them to me in email. Now, if you do hand in a lab late, don't forget to email me so I know to go look for it and grade it in Blackboard. And with that, I'm done for the semester. The first day I talked about my world of chemistry is your world of chemistry. You don't know about it, but, I almost forgot one more thing. Let me go back and do it. Almost forgot this. All right, what I almost forgot, bad Dr. White. You should know, how does soap work? Soap soap has a nonpolar tail and a polar head. Remember the important piece of the puzzle: light dissolves light. Water is polar, dirt and grease are nonpolar. I even have on here, know this. And you form a micelle. And a micelle, and only putting a few molecules of soap, there are a lot more like in this picture. The outside of since dirt is nonpolar and the tail of soap is nonpolar, the tails attract to the dirt. Now, the polar heads of soap want to be as far away from dirt, so they're on the outside and they surround this to form a micelle. And now water looks at a micelle and only sees the polar heads of the soap on the outside and says, oh, micelle, you're polar, I'm polar, light dissolves light, let's go down the drain together. And they do. And that's how your hands and everything else gets clean. And you should know this. Hint, you should know this. And now I can start again saying thanks for being in the semester. Don't forget to write something and ratemyprofessor.com. Also, don't forget to do the assessment exam before the end of finals week next week. It doesn't count anyway, affect your grade, but be with you in a second, Jim. But please do that. It helps us a lot, the chem department, so please do that. And my world of chemistry is now your world of chemistry. I hope you enjoyed it. Chemistry is fun. I've enjoyed it all my life. I hope you enjoyed it this semester. With that, I'll say "Gehen gesund," which means go in health in Yiddish. And I'll say bye now. I stole that from Granny and the Beverly Hillbillies. Bye now.